Hey everyone, it's Mr. Aaron's. I'm hoping that you're having a great Monday. Back to school, back to work. We'll get back into the swing of things here. We're starting a fresh chapter, chapter 5, which is titled Operations with Fractions. So we're going to be doing a lot with fractions. We have a 2-day lesson to start off here. So we're splitting 5-1 into 2 days. It's called Comparing and Ordering Rational Numbers. But today we are going to be looking at least common multiples. We have worked with least common denominators. This is going to be similar to that, but a little bit different. You'll see some similarities as we dive in here. All right. So our first definition here is a multiple. Multiple is probably about what you'd imagine it would be. It's the product of a number and any non-zero whole number. So a lot of times they'll tell you to find the multiples of something. So we're finding multiples of 4. We're finding the multiples of 6. And all that means is we're going to do 4 times 1 times 2 times 3 times 4 times 5 times 6, and so on and so on. The multiples go on forever, all the way to infinity for each number. So right here I wrote out all the multiples of 4 up until 6 of them or so. And 6, I did 5 of them or so. So I did 4, 8, 12, 16, 20, 24. Something you're probably familiar with. Those are our multiples. Common multiples are multiples shared by 2 or more numbers. So if we're looking at our common multiples and we look up here, I'm going to see what they have in common. Do they both have a 4? No. Do they both have an 8? No. Do they both have a 12? Yes, they do. There's a common multiple right there. They both have a 12. There's one other common multiple in here. See if you can find it. I'm sure you found it by now. They share a 24 as well. They have more multiples in common as well, but these are the ones that I wrote out. So our common multiples would be 12 and 24 for the numbers that I've written. There's obviously more if we go further in. And our next word is our LCM, our big word of the day. Our least common multiple. This is going to be the lowest shared multiple between 2 numbers. So if we're looking back ahead here, I'm thinking, what is the smallest number that they have in common? We have 2 options here. We have 12s and 24s. So our least common multiple would be 12, as it is the smallest number that they have in common. That's a pretty simple way to find the least common multiple. For larger numbers, it's going to be a little bit more difficult, but we're going to practice this method a little bit more here. Basically, you're going to list out your multiples and then see which one they have in common at the very smallest. So I'm going to start by listing out my multiples here. We're going to do it for 5 and 6. So I'm going to do 5, 10, 15, 20, 25, 30, 35, and we'll stop there for now. 6s, we're going to go 6, 12, 18, 24, 30. Oop, I noticed something already right here. Their lowest common multiple, they both have a 30. That is our least common multiple. We can stop right once you see the same in both. So I just listed off all of the numbers, multiplied it 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. And I found that they had 30 in common. Super quick, super simple method for doing that. We're going to do a couple more examples here. I'm just going to make this real quick for you. We got our 3s. Let's do it. 3, 6, 9, 10, 12, 4. I messed up here. This 10 should not be here. 3, 6, 9, 12, 15. There you go. 4s. Let's go. 4, 8, 12, 16. I see it right there. They both have a 12 in common. 12 is our LCM. Our next one, we got 4 and 5. Let's do it. 4, 8, 12, 16, 20. I'm going to stop right there. 5s, we got 5, 10, 15. I'm sure you're already thinking it. There it is. They both have a 20 in common. We can stop right there. Their least common multiple would be 20. LCM, least common multiple. We got one more here. I think this one might take a little bit because we are doing 3 numbers. You don't always have to do it with 2. You can do it with 3 and then find which one they all share. Let's start here. Let's go. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 30. I know which one I have to go up to, so I'm just going to keep going. 39, 42, 45, 48, 51, 54, 57, 60. I'm going to stop right there. A lot. I should have given myself some more room. I'm going to do my 4s over here, actually, so I have a little bit more room. 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 52, 56, 60. All right, and 5s, 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60. And you notice the number that I stopped on all of them is that least common multiple. I knew it going in, so I knew where to stop. You'd have to be a little bit more careful while you're checking these, but I know it's going to be 60 because I did this one in advance. I wanted to do it quick for you. I didn't want to have to sit here and think about each one. But if I scan through all these, there's some that 6 or that 3 and 4 will have in common, and there's some that 3 and 5 will have in common. There's some that 4 and 5 will have in common. But we're finding them for all 3. If they give you 3 numbers, you got to find the least common multiple for all 3. All right, so that's the quick way to do it. Now a little bit more complicated way. This one I am showing you because it can come in handy in a lot of situations when you can't list off those least common multiples like that because your numbers would get way too big. You'll see an example of that right here. So we have are going to be using a prime factorization to find our least common multiples. So what we're going to do are these 3 steps. I wrote them out for you here if you'd like to jot those in your notes. That'd be an awesome thing to have on for your tests and quizzes. So step 1 is to write that prime factorization. We did that before Christmas or before the holidays. So we're going to go over that. Just as a little refresher, I think that should come back to you pretty quick. And then we're going to take the greatest power of each factor. This is going to be something that's a little bit new, but I'll show you how to do that. And then we're going to multiply them all together. So we're finding our least common multiple of 12 and 40. This method, we're going to use that prime factorization. So I'm going to start by doing that. Remember, to do that, we just break down a number all the way until it cannot be broken down anymore. So we're thinking multiplying 6 times 2 is 12. To get to 6, we do 2 times 3. These are all prime numbers. They can't be broken down anymore. 40, let's do 4 and 10. And we'll do 2 and 2. And we'll do 2 and 5. All right. Then over here, what I'm going to do is I'm going to write out the prime factorizations. Remember to do that, you use exponents. So for 12, I have 2 2s and 3. I do those in numerical order. For 40, I have 3 2s and a 5. So we got done with step 1. We wrote out our prime factorizations of both. Our next step is to take the greatest power of each factor. So what that means that we're going to do is for every different number we have here, we're going to take the largest version of it. This one will look pretty simple. What we're going to do here is I'm going to look at my 2s and think which one is bigger, 2 to the second or 2 to the third. 2 to the third is bigger. That is our greatest power of this factor. So I'm going to take this 2 to the third out. Then I'm looking at my next factor. My next factor that we have is 3. There's only one version of 3, so we're going to put that one in. And we're looking at our next one, our greatest version of 5. And put that one in. If we multiply all these together, this will be our LCM. So I'm thinking 2 to the third, 2 times 2 is 4, times 2 is 8. 8 times 3 equals 24. 24 times 5 is going to be 120. Our LCM is 120. So I took the biggest version of 2, the biggest version of 3, the biggest version of 5, because those were all numbers that we had hidden in here. You'll see another example of this. I think this will make a little bit more sense as we get further into it. All right, so right here again, starting with that prime factorization of 6 and 16. This is a different version instead of listing them off like we did earlier. So I'm going to split this up into 3 and 2. 16, let's go 4 and 4. Split that up into 2, 2, 2, 2. Perfect. Write out those prime factorizations. 6 is going to be 2 times 3. 16 is going to be 2 to the 4th power. All right, so I'm looking at my factors here. I'm finding the greatest power of each factor. So I start with my 2s. This is 2 to the first. This one's 2 to the fourth. So this is the bigger one. We're going to take that one. 2 to the fourth. And 3, we only have 1 3. So we're going to take that one right up here. And this is going to be our LCM. We used all those factors that we had. We used a 2 and a 3. And we multiply them together. 2 to the fourth, I know that is going to be 16 times 3. That would be 48. All right, the reason that we're doing this is why right here, why we're doing that prime factorization is because sometimes you're going to have some variables. And you're going to need to do this because you can't just list off all of the common multiples. You can't do this because we don't know those of these. That's going to be a little harder to do when we have variables in there. So I'm going to show you how to do this. Our first step, just like we did for our prime factorizations, we're going to break these apart. 6, we're going to make 2 times 3. 18, let's do 2 times 9. Split apart 9, 3, and 3. Now we're writing down those prime factorizations. Remember to do this. We're going to do 2 times 3 times, don't forget this a right here, this a squared, times a squared. We need to keep those variables in there. We took them out while we did our factor trees, but we got to punch them back in when we do our prime factorizations. 18, we have 2 times 3 squared times a to the third. Okay, we have to pick out the greatest power of each factor. So first 2, they both are just 2 to the first power, so we're just going to take this one. Doesn't really matter which one we take. 3 is, I have a 3 to the first power and a 3 to the second power. I'm going to take that 3 to the second power because it is the greatest factor of them. And our a's, we have an a to the second power and an a to the third power. We're going to take a to the third power because it's bigger. Finally, connect these up. This is going to be a 9 right here. 2 times 9 is 18 times a to the third. 18a to the third is our least common multiple. We did the exact same method as we did for those first two. I'm going to show you one more here, and then I'm going to sign you off and send you on your way. Okay, we got 25y squared and 15xy. Take out those numbers right away to break those apart. Let's do 5, 5. Oh, look at those are prime. 15, we'll do 5 and 3. Also prime, we're done right there. Okay, so I'm going to write this out as 5 times 5. Oops, that's not how I want to do that. 5 squared, excuse me, times y squared. Remember, I need that y squared in there because I got it sitting over here. I got to put that back in for my prime factorization. And 15, we're going to do 3 times 5 times x times y. I broke these apart to x and y, just like this right here. Now we're going to take our greatest power of each factor. Our first one, we have a 3. We only have one of them, so this is what we're taking. Take that 3. We both have a 5. Which one are we going to take? The bigger one, 5 squared. Perfect. X, we only have 1, so we're going to take this x. Y's, the bigger one is our y squared, so we're going to take that. Put it all together, 5 squared is going to be 25. 3 times 25 is 75. X, y to the second power. That is going to be your LCM. Make sure to hop into my office hours if this is confusing for you. I'll have that live lesson as well at 10 o'clock. That's day 1. I'll see you again tomorrow. Good luck.